A very good day. My name is Dineshwaran, unlike Igunasegaran, and my metric ID is MA19091. So now I would like to start the introduction of our experiment 5, the Pelton turbine. Okay, a Pelton turbine is a type of hydro turbine used frequently in hydroelectric plants. So, in a Pelton turbine, it consists of an element called a Pelton wheel. The Pelton wheel extracts energy from the impulse of moving water as opposed to water's dead weight like a traditional overshoot water wheel, which then transmits power to the machinery. The Pelton turbine has a straightforward layout design which tenders a simplistic ideology. So the above is a Pelton wheel. Okay, now the design of Pelton turbines. So the design of Pelton turbine is follows a simplistic ideology. First, a large circular disc is mounted on a rotating shaft which is known as rotor. Mounted on the large circular discs are cup-shaped blades known as buckets, which are evenly spaced between each other around the entire circular disc. So it's evenly spaced between each other, like around the rim. The Pelton wheel is then equipped with nozzles that are used to feed water into turbine, causing the Pelton wheel to spin and the rotor to rotate. So the spinning of wheels and the rotor to rotate causes power transmission to the machinery. These nozzles produce tangential power to the turbine wheel water jets. So this causes the Pelton to spin as a result of impact of the water jet. So the impulse and impact of water jets causes the wheel to spin and the power is then transmitted. So the below is the simplistic design of a Pelton wheel. History. L.A. Pelton is an American engineer who performed notable research in order to determine the best shape of the buckets. So at that time he developed the Pelton water wheel, which was the impulse water turbine's most effective design at that time, which was in the late 1870s. So Pelton's suggestion for enhancing the turbine water wheel originated from his research of the machinery and methods using in mining in the California Golden Rush region. So he was the founder and developer for the Pelton water wheel, which has contributed worldwide. So the objectives of our experiments are: firstly, to evaluate a Pelton turbine's effectiveness while taking into consideration both the power output and rotation speed. Second is to determine the power curve by using rotational speed and power out and its performances. Third is to measure the power out, power in and efficiency with given rotational speed and torque. So these are the three objectives, and we have proudly achieved it. The scope. So the scope of this experiment is that the Pelton wheel turbine is known for its hydroelectric usage to generate power and energy. Hence, there is a need for a study to be conducted to understand about the source of power supply throughout this experiment. And we have successfully understood and achieved these objectives. By carrying out this experiment, it provides us with essential information on the occurrence of variations in rotational speed when pressure and flow rate are maintained continuously or as a constant variable. And also we have discovered how these factors affect power, power torque and effectiveness. That's all for now. My group mates will continue the presentation. Thank you.
Assalamualaikum. I am A1919 Muhammad Iqmal Haikal bin Rahim. So today I want to explain about our part is the literature review for our experiment. So first I want to explain about the Pelton wheel turbine. A little bit explain. So Lester Alan Pelton, an American inventor, developed the Pelton wheel in the 1870s. The Pelton wheel is a type of impulse turbine that generate electricity by using the energy of boiling water. It is composed of a series of cups or buckets set around the rim of big circular wheel that is linked to a generator, and Pelton wheels are commonly used to generate electricity from the energy of boiling water in hydroelectric power plant. Next, I want to explain about the design of Pelton wheel turbine. So this is a diagram for Pelton wheel turbine design. First, the runner. It is the core part of the Pelton wheel and is normally constructed of a cast iron or steel. Second, it consists of a series of cup or bucket set around the rim of the wheel. and designed to catch and redirect falling water. Third, the cup and typically designed like half sphere or parabolas positioned around the perimeter of the runner to enhance momentum transfer from the water to the wheel. That's the nozzle. Nozzle is usually found at the top of the penstock, which is a pipe or tunnel that transport water from a tank or other source to the pattern wheel. The direction and velocity of the water as it strikes the blade are determined by the design of the nozzle, which is important to the effectiveness of the pattern wheel. The lastly is a generator. A generator is a piece of equipment that turns mechanical energy into electrical energy. And the generator size should be determined by the quantity of mechanical energy available from the pattern wheel. And lastly, the generator should also be constructed to drive at the optimal speed for the pattern wheel, which will be determined by the water flow condition and the size of the wheel. So, firstly, I want to explain about the component of pattern wheel turbine. This is a pattern wheel turbine line diagram. As you can see, at the diagram, we have a penstock, casing, vents, runner, nozzle, jet of water, and sphere. So I want to explain the component they have been at diagram. First, the runner consists of a scalar disk of the periphery where the number of bucket is fixed. The second, the nozzle. Function of nozzle is water from the reservoir is accelerated to a certain velocity. And penstock, these are the channel of pipe through which water from a hard head source is delivered to the actual power station. Then the casing component is to function to prevent the splashing of water and to discharge water to terrace. Sphere. The function of sphere is depending of the size of the unit, a conical needle driven by hand wheel or automatically in the axial direction. And then lastly, for the component of pattern wheel, governing mechanism. The function of governing mechanism is to monitor and control the speed of the turbine runner. So that's all from me. Thank you.
My name is Muhammad Dino Bizrifli and I will be presenting for the methodology for this experiment. Okay, the first is apparatus. There is 3 apparatus that we use in our experiment, and the first is Pelton turbine, which consists of the first is spring balance, second is manometer, the third is nozzle adjustment, the fourth is the nozzle, the fifth is Pelton wheel, and the sixth is brake adjustment. The next apparatus is hydraulic bench, which consists of flow control valve, the overflow, the storage tank with pump, the valve, the measuring tank level, and the measuring tank. And the last apparatus that we use is stopwatch, which is to measure the time. Okay, and this is the experiment setup that we use in our experiment. You can see that the Pelton turbine is on top of the hydraulic bench. Okay, next is for the procedure. The first is switch on the pump which attached to the hydraulic bench. Second is fix the stopwatch to 0. Third is the valve at the base of the volumetric tank is shut. When the water reaches 10 liters, the stopwatch is started simultaneously, and once the water level reach at 2 to 30 liters, stop the stopwatch. Jot down the high value of water in the tank and the measured time. And last is repeat the experiment with different nozzle setting.
Hello everyone, my name is Madhavan Sanam Sivaraman, metric ID MA19090. Today I would like to talk about the results part of experiment 5, which is Pelton turbine. So let us look on the first output of this experiment, which is experimental data. So for the turbine characteristics curve, first of all, it was instructed for the fully open and a constant pressure which is 0.2 bar, and also a constant flow rate which is 30.9 liter per minute. So these are the data we obtained for this experiment, which is for the first, we can see the given data is rotational speed. The second one is the moment on the shaft. The third one is power output. The fourth one is power in, and also the finally one is the efficiency. So let us convert the pressure. 0.2 bars is equal to 20,000 Pascal, and also the flow rate is changed to 0.000515 meter cubic per second. So let us look on the power curves. Same case as turbine characteristic curves, but for the power curves, we only having the rotational speed and also power output, and also the different value for the flow rate is 18.75 liter per minute. Let us also convert here the 0.2 bar to Pascal, which is 20,000, and also 18.75 meter per minute is equals to 0.000325 meter cubic per second. Now let us look on the graph section for the first graph, which is torque versus rotational speed. So these are the moment of the shaft versus rotational speed graph. The relation is when the rotational value rises, the moment of the shaft decreases. Let us look on the power output versus rotational speed graph, which is the second graph of this experiment. Here we can see the trend is when the rotational speed increases, the power output become lesser. So this is basically for the power output versus rotational speed graph. And the third graph is efficiency versus rotational speed. Same as for the power output, the efficiency seems like similar to the power output, which is for this graph we can see that when the rotational speed is elevated, the efficiency is reduced. Next we will look on the power curves, which is the additional calculation for this experiment. For power output versus rotational speed, we can see the trend is actually same like the efficiency versus rotational speed graph, but it's actually for the power curves. Finally, we can do the comparison for the turbine's characteristics curve versus power curves, which we can see power out versus rotational speed graph for the flow rate. First of all, we can see for the 30.9 liter per minute flow rate, which is the graph is actually rises, the trend is actually rises, and also it's decreases to the zero. And then for the 18.75 liter, we can clearly see that the graph is actually from higher, it goes to the lower. So for the conclusion, we can make that the power curves provide more output in the form of power than turbine characteristics curve. So that's all from me. Thank you.
Assalamualaikum and very good morning to our members. Today I'm going to present to you about the discussion for our experiment 5, that is a Pelton turbine. So my name is Muhammad Aiman Arif and my number ID is MA19050. Okay, first we go to the page 1. There is a graph. There are two graphs for this experiment. There is graph torque versus RPM and power output versus RPM. For the torque versus RPM, the x-axis is rotational speed and the y-axis is movement of the shaft. For the power output versus RPM, the x-axis is rotational speed and the y-axis is the power output. Okay, next we go to the maximum torque produced by the turbine, that is 0.62 Nm, and the maximum output from the shaft because the nozzle is 4.5 watt, and the efficiency of the turbine is 50%, and the maximum power of the turbine can be produced is 3.08 watt.
A very good day. My name is Dineshwaran Secret. My register is MA19091. So we have reached to the final part of our presentation. So there are several tenets which we like to render here this conclusion. And in this conclusion we have we would like to proudly say that we have achieved all of our objectives. So now, as you know, Pelton wheel turbines are hydraulic turbines used in hydroelectric power plants to generate energy. So this is the basic mechanism and function of Pelton wheel turbines. So there are three major outcomes derived via this experiment. So first, at constant pressure and volumetric flow rate of water, it is shown that rotational speed of Pelton wheel turbine affects the power and efficiency. So this is our first conclusion. Second, from the results obtained, we've derived that when the rotational speed of the Pelton wheel increases, the maximum efficiency will decrease. So this is the second conclusion. The third conclusion is the rotating speed of the Pelton wheel turbine influences power production and efficiency at same volumetric flow rate of water. So these are the three main tenets which we derived and rendered to you. So that's all for now. We would like to end our presentation here. Thank you.